button. We are now recording. Okay, so last time we created a flat panel system using the Lunchbox toolset to create a triangular kind of grid, and from that generated a triangular volumetric surface that opened and closed with the slider. So tonight we're going to do that same or similar thing, but this time we're going to do it on a curved surface, on a lofted surface, and we are also going to add in, like I said, the Ladybug tool set to make it dependent on radiation levels at different time, a different day or time of day, or throughout the year. So first and foremost, I'm going to grab the curves that are in the only thing I have in Rhino are those two curves, nothing else. So I'm going to grab those curves out of Rhino into here, and first thing I'm going to do is loft them to create my surface that I'm going to put my my triangulated surface on, right? So super simple. I got my curves, I got my loft command all set. And as we learned with the Lunchbox tool set, that's Ladybug. Lunchbox tool set, to create a panelized system, it's pretty simple. In this panels, I'm going to use the same panels I used before, this triangle panels B. Plugging that in, you can see that it automatically generates my triangulated surface on top of my curve. I'm going to add in two sliders to control my UV divisions, so that I can make more triangles in both the U and V direction, because I want them to be a little more tightly spaced than maybe something like that looks good. So pretty simple to get, only 5 nodes. We already have a triangular gridded surface on top of our surface there. And if you remember last time, we did a few things. So one thing we wanted to do was get the center point of all of these triangles, and the other thing we wanted to do was get the vertices, or the segments of all these segments and vertices of all these triangles. Does anybody remember how we got the center point?
Area?
Yeah. It's my favorite. What's my favorite way to get a center point? So the area command, said it 1,000 times, but it automatically gives you the centroid of any shape. So plugging those panels into here, you can get the center of all those triangles very quickly. Anybody remember how I got? So these are all these lines are all they're panels. But does anybody remember how I got the vertices? Or got one out the vertices, and made these lines so I could grab them individually.
Explode?
Yeah, so there's a curve explode tool. Throw that in there, and then if I, so now I have, if I was to get a list here, you can see that I have all the vertices of the different connection points. And if I pop this up here, this is all of so this is just the first list of lines. So that's the one set of lines. If I zoom in and I add, I can grab that set, and I can grab that set. So this is all of them, but they're exploded into individual lines that we can grab. Similar to last time, I'm just going to add a curve command here, and I'm going to plug that into these. It doesn't change much. It's just I want to use that as my separation point here. So similar to last time, I'm gonna attack this as a singular triangle, one at a time. So if I plug my list in here and I grab, if I bring it down to one item, I grab just this singular triangle here. This is just, like we said last time, it's just a little easier to work on one and then apply it to all of them together. So I'm just gonna turn off my preview for my surface so I can just see the triangles. So with that, I am going to delete this for a second. So this, I will eventually circumvent this and plug this guy back into these. But for right now, I'm going to circumvent that to work on just this singular triangle. So does anybody remember what we had to do from here? So before, last time we're basically creating we're taking this center point, we're moving it outwards, and then we're kind of creating a pyramid shape using all the various points and lines to create faces. Does anybody remember how we moved this point before on the previous time we talked about this? Nobody? So last time we just used the move command. Before when I did this last time, we had a plane, just a plane that was in the YZ or XZ direction. So it was a plane that ran along this red line and went up in the Z direction. So all I had to do was use the move command, like so, plug my geometry into here. And then before I used the Y vector because I wanted to move it in, the direction in the Y direction. So when I plug this in here, so this is actually probably not the best one to use. So right now it looks okay, actually. It looks like it's moving kind of in the right direction. But does anybody know why this is not going to work for all of these triangles?
Because it's not like the main shape.
Not like the main shape, kind of.
Each centroid is like a different UV position.
Exactly. So if I was to move my triangle here, so I just plugged the number 8 into this index. So now I'm grabbing the 8th item in this list. You can see that my point is moving in the Y direction, but it's not really moving. I don't want it to move horizontal to this XY plane. I want it to move perpendicular to the plane of this triangle. So plugging Y into here isn't going to work. If I plugged a Z vector into here, it might look like it's working, but it's still not perpendicular. You can kind of tell if I was to, I don't know if that'll make it look, just create a surface out of this triangle. So you can kind of tell, I hope you can tell. If you can't, let me know, but you can tell that point is not perpendicular to that triangle. It's at an angle, right? It's straight up, but it should be more this direction. So does anybody remember, we talked about it a little bit last time, how do we find what is perpendicular to all of these triangles? Because they're all different. We learned this term, we talked about it probably 15 times so far this semester.
I think it has something to do with the normal.
Yes, the normal. So we need to find the normal of all the various triangles, because the normal is a vector that is perpendicular to the surface, or kind of perpendicular to a point on that surface. So if this was a curve, if we got the normal on the curve, it would be perpendicular to that very specific point related to the surface. This one we wanted, this is a surface, so it kind of has a perpendicular plane that comes out from this surface. So we need to find that. So luckily, it's not too difficult. There is a node called evaluate surface. You can even see that it kind of has a little diagram of what the normal is. So this guy will punch out all these various items from here. The main one of what that we care most about is this normal. So I want to plug my surface in. So what do we think? What do we think we need to plug into that surface node there, connector? We want to plug in this loft, right? So this is where I hit it right now, but we want to plug in this curved surface here, and I'll turn that preview back off. So I'm going to put in that in there. Does anybody want to know? Does anybody have an idea of what? Are
we offsetting that next?
No, I'm trying to remember.
Oh, sorry.
No, sorry. Yeah. So we need to plug in a point, right? So we don't. I'm not currently getting anything out because I don't have a point. I have not connected a point to here. Anyone have an idea of what kind of point we want to plug into that, or what point we want to plug into that to get the normal from?
The centroid.
So the centroid is what we would assume that we would want to plug into there. So that will get us some weird thing over here, right? This is showing so that doesn't look right, right? That point does not look, that point is not normal. It's not, does not match up with this. It doesn't align with the, with where I want it to be. So that's, something's not correct, right? Where's that one? Oh, that one's way up there. Okay, so he's just moving the Z. So so the reason being is that if I hover over this point, I was like, why is this point not showing the right thing? It's because it's looking for a UV coordinate to evaluate a point. This is not a UV coordinate. This is just an XYZ coordinate. So we need to convert this point into UV coordinates, or into a UV coordinate. So I need to, let me just check actually. I did this before. Believe the node surface. So what I want to use, because if you really look, this isn't a perfect, if I turn my surface back on, enabled, not enabled, I want it enabled. I don't want it previewed. The panels, which are also hidden, are not perfectly aligned with the curve because these are straight. They're not. It's creating a faceted surface. It's not matching the curved surface exactly. So it's kind of creating faceted surface connecting these various points. So when I grab the point from here, actually, I wonder if, I just had an idea. I actually did this differently before, so maybe, I wonder if this will do what I want. No, it's not going to do what I want. Sorry, I just had a different idea, a different way to solve this. Let me put this back in. So this point, the centroid point of this triangle and this surface, they're not actually on top of each other. It's hard to see, but they are. I wonder if I can see it in a side view here. Preview, preview, centroid. So you can see that the centroid is kind of in a different plane. Here's my curve. This black line is my curve. The centroid is not really falling. Should be in theory in line with that curve there, but it's not. So what we want to do, what I got, what this node is called the closest point, surface closest point. So what this does is it says, I have a point, I have a surface. Find me a point on the surface that is the exact, that is close as it can possibly be, right? So if I was to plug in my loft here to the surface, and then I plug in my centroid to here, you'll see that I now have a point right there, which is on the surface that I'm talking about. And then if I plug my point into here, I believe that will get me where I want it to be. So if I plug my normal into that, so now you'll see that this point, let me just check something out here. Maybe, oh, maybe it does work. Okay, maybe I was wrong. I apologize. I thought I had to do this for some reason. It looks like it's working here. I'm gonna leave this here for now. I feel like when I was, kind of gaming this out earlier, I needed that for some reason. I can't remember why. So it looks like I was incorrect that this will still work. But I'm gonna leave this here just in case I have to bring it back. Anyway, actually no, I'm gonna plug it in because I don't want to find out later. Sorry. So I now have my point moving in the right direction. And if I was to turn on, let's see here, if I was to turn back on all my surfaces, which I can do, I will, if I plug this into here for a second, I now have all of these points that are moving normal to their specific spot in their triangle, right? So these ones are moving upwards, these ones are moving outwards. They're all moving in the right direction because if I looked at this normal again, coming out of here, you'll see that I have a whole list of different vectors. And that's a vector for every single point on this triangle, on all these triangles. So, it's grabbing the right direction for all of them. So I'm just going to plug my list back in here. So I'm only working on one. I got my triangle there. I'm going to preview that. But I'm going to turn this back on. Right there. Okay. So I got my triangle. And I got my normal. So now it's not too dissimilar from what we had done before, right? So if I wanted to vary the depth of this, does anybody know how I might? So before, when we did this, I varied the depth by changing the factor of the vector. Anybody have an idea of how I might want to, if I wanted to, have a slider that moved this point in and out, how I might do that? Because now I don't have a vector, when I put in a vector, I have a factor that I can plug in here, but I don't have a vector command. So does anybody have an idea of how I might change the depth of this point?
Offset something?
Offset something. That's a, that's one way to do it, I guess.
Can you put a slider in between the normal and motion?
Slider in between. So a slider only has the one output. right? So I can't plug anything in on this side. You're not, but I do need a slider. All I need to do, anybody else have an idea? Offset, it wouldn't be terrible, or you could, in theory, take this point here and do an offset, or you could do another, I guess you could do, is there an offset for points? Plain offset, point list, what do I got in my vectors?
My thought was kind of like you offset the surface that the point's on and then like find the point again. But I know that's like extra steps.
Yeah, you probably need a few nodes. You, in theory, could do that, but you probably need like, 4 or 5 nodes to do that. All we actually need to do is go away. All I need is a math operator and multiplication. So all I need to do is say, take the normal, put it into there, take my slider, put it in there. Let me change my slider to be a max of, let's say 5. And then I plug this result into there. And now I can just move that in and out with a slider. I'm just multiplying the, it actually doesn't look 100% right. But I can move the slider in and out and move that point in and out as well. All right, so simple as that. Just adding, taking the, because these are just numbers. These are just, well, they're not numbers. They're directions, right? So we're just multiplying that out to make it, deeper. So got that, and then everything else is kind of similar to what we did before. I need to get all of my various lines. So this is where my segments here is where my lines are my segments. And I want to grab all those individual lines so that I can, draw my my faces, right? So if I zoom in here, that first line is that top one. Put this like that. And I can add items. I can grab that one as the second, and that's the third. So I know that the I here is this line, the +1 is this bottom, and the +2 is this side. I can do the same for my vertices. I'll just close this out so you can see. So that vertices is the top one there. I can add to it the left one, the bottom one, right? So that gives us all of our various points that we can grab and start to draw lines with. So we did this last time. I'll just quickly run through it again. I want this to be my start point. I want this geometry here to be my endpoint. So I get my first line. I can create my third line here by just doing that. Copy, paste, and my fourth line, or my third line there. So now I've created my little pyramid. I can use these lines and these lines to create my faces. So I'm going to go to surface. I'm going to create boundary surfaces here. And I'm going to start plugging in my lines. So I believe this is this line here. And I can hold shift, I can add that. And then I can hold shift and add that. And now I have that surface. I can now start to add these other ones. So I want, delete this line, and then I want this line into here. Got that one. This last one here, that. Probably want this line holding shift, and this line holding shift. And now I have a triangular surface using that is now, it has one slider controlling it, pushing it in and out, making that triangle a little deeper. So we got that. So this still doesn't look like it's a perfect normal. It's kind of bugging me a little bit. I wonder if it has to do with what I was doing down here. Yeah, I'm not sure. It might not be it might be because I'm using the curved surface, and it's normal. It's a perfect normal from the curve, but not a perfect normal from this face. Well, I'll ignore that for now. But you know, in theory, I could probably fix that by grabbing this bottom face and making it normal to that rather than the curve. Anywho, so now we have our surfaces like so. Then our next step was so we can do the rotation from here as well. So I can rotate on my axis, rotate axis. Some of you were doing kind of some rotation, some things, and we had to run through them, but just as a refresher, the rotation on an axis basically takes a piece of geometry, so I want to rotate that surface. It takes an angle, which is in radians. So I'm going to rotate mine to, you know, up to, let's say 60 for now. So this right here, this node that I'm going to plug in here is actually the node that will replace, you know, by the end of class, that we're going to replace with the data coming in from the Ladybug node. So this one we can even, you know, group this. So that way we can find it later. Replace me, but we'll do that at a later time. So there you go. So I got my radians plugged in here, but you can see that I'm not rotating along the right spot. So I need to rotate along the axis. The axis I want to rotate along is that line. So I just need to find where that line is. I believe it's this I right here. And you can see now it's rotating in the right direction, or rotating along the right axis. So I'm just going to hide these real fast so we can just see that curve. And then we do the same thing for the other surfaces. Plug my geometry in. I want to keep the angle the same because I want them to rotate similarly. And then the axis for this one is, I believe, the 1. Yep. I'll turn off the preview. So now I got 2 rotating like so. And then I'll do the same thing for the last one. And that's going to be this 2, axis there. And you can see that I now have something that is rotating in and out and creates my opening. So now I just need to apply this to the entirety of my whole surface, because we, like I said back here, we were pulling out this. We're pulling out only that single triangle. So before I do that, before I if I just plug this node into these two without doing something else first, you know, my computer will attempt to do some crazy calculations and crash. So temporarily, I'm just going to turn off this enable, so that it's not whenever you disable a node, or I guess toggle the enabled, it basically just past that node, it won't do anything. So if you remember over here, I had to graft this this node coming out of here so I can get my list working properly. And then if I plug this back into here, this into here, circumventing this guy, and I re-enable this, it's going to take a second, but now I have all of my triangles, all of my doing their thing. I can move them all in and out. Takes a second for them to kind of react, doing a lot of calculations. And then I can come over here and open and close them all, make them all 0 and close. I can make them all, 60 degrees and open. But they're all manipulating at the same, at the same degrees, right? So that's what we're going to try to change, or we're going to change with the Ladybug stuff. Does anybody have any questions about this outright. You know, getting the normals, moving those points, creating these surfaces, rotating them, and so on and so forth. Okay. Is anybody, my understanding is you have started to use the Ladybug tools in your other class. Has anybody had any luck playing with them or getting anything out of it?
I haven't had any luck.
No, you have not had any luck. Okay. Well,
I haven't had any either.
well, we'll see if let's see if what I show you helps. It is a very complicated plugin, as obviously you've probably seen. So it can be tumultuous to deal with. One thing I'm going to do quickly is I'm going to join all of this geometry into a single node, this brep join, and then hide this so that I can select all of them at once. And so when we want to bake these things in and out, all I have to do is bake this single node there. But everything still works even with that joined. So let me just hide these. Oops. Hold on a second, my door's opening and closing. 1 second. Sorry, I have the windows open and my doors, there's a ghost bumping in and out. It's driving me a little crazy. So anyhow, back here. So we're going to start playing with the Ladybug tools and try and get this to be reactive to the sun. So with Ladybug, right here, you have all this crazy stuff, and you know, all kinds of nut stuff up here. You can look at the sun, you can different radiation, you can look at human to sky relation, visibility percentages, incident radiation, which is coincidentally what we're going to do. You know, all kinds. See the sun path, various diagrams that it can create on top of your project. So all kinds of cool stuff in here. We're gonna particularly look at the incidence radiation, which will tell us how much radiation is on a given surface or given point in our surface at a specific time of day. But if you bring this in, you need 50 nodes. You need like 1, 2, 3, 4, 5, 6, 7, 8 different things plugged into here to get it to work the way we want. So we can't even really start with this because we need to pull in all of the weather data, right? So I'll leave this open, but the thing we need to bring in is a EPW map. Is everybody, I'm assuming you've heard of that. So this command right here, the import EPW, is kind of the start file for most of these things in Ladybug. Have you guys heard, I'm assuming when you learned about Ladybug, you learned about EPW files and where to find them?
Yes.
Okay. So I downloaded one, but I'll download another one. It's down here. So I'm sure you've EPW map Ladybug. You can go to the EPW map Ladybug tools, and you can hunt these things down anywhere. So somebody pick a spot, pick a location anywhere on the planet.
Mozambique.
Oh, geez. All right, now you draw where Mozambique is, and I will go pick that map. Somebody point to Mozambique.
Somewhere, I don't know.
I literally have.
Pick right here.
Oh, right where?
Right there.
over, oh, we're going Western Sahara. Okay, let's do, what is this? What's that place? Dulka. Let's try that. All right, so I'm going to copy that. I'm going to paste that in here. Oh, fail. Looks like that one wasn't found. Let me try that again. Doesn't look like that place is going to work.
Mozambique is over by Madagascar.
Oh, that's like out here in the ocean, right?
Well,
There
it's
we are.
from Africa.
Yeah. So let's go to Pemba. Is that Mozambique still? Yeah, let's go to Pemba. Let's see what we can get out of Pemba. Maybe we can get a map from there. There we go. Pemba's got a map. So let me grab this. I'm going to copy that into a folder here. So you got to download that map. You got to save it in a place where you know where it is and you can guide your script to. Let me put it here. It's a zip file. Let me just unzip it real fast. Extract. Okay, so we got our Pemba map here. So let me go back to Rhino. So I need to grab a file name or a file path, which is right here in the primitive, in the params primitive section. I can get a file path. I'm gonna right click on that, select one existing file. I'm gonna go into Pemba and grab my EPW map, open, and plug that bad boy in there. So now I now have a regular node, and from this node you can see this file has all this different information of this site, and this this node is pulling all of it out separately, right? So with this, we should be able to start to get some of the data that we need for this. But you can see none of this isn't pulling out any of these items. It's, we need a sky matrix, geometry, we need all these different things, but none of that stuff aligns with this. So we still need to get some other items. So what I need to grab, go back to Ladybug. I believe it's this guy right here. Yeah, I want to grab first thing I want to kind of grab is going to give me a lot of my information, or the main part of my information is the sky matrix, right? So if you hover over this, you'll actually see all these are the 4 inputs that are required to run. So you don't need to plug in all of these things, but these ones definitely need to be plugged in for anything to function. So I'm going to grab my sky matrix. So you can see right here, this is the cumulative sky matrix. And I can, using this, grab my location. If I hover over this, you can see what else I need to grab. I need my direct radiation and diffuse radiation. So I have that right here, direct radiation, my diffuse horizontal radiation. You can see that flips over to running properly, but it's still not going to get us everything we need. So I'm going to plug my sky matrix in here. But what I really want to do is I want to be able to tell this when to what time of year, what day, or what days to grab the information from. So this HOYS, which is what is it? HOY hours. I think it's hours of the year is what this is. Number listed to represent the hour. Yeah, hours of the year to generate the sky matrix. So this is basically, you could grab it on a specific hour in the year. But the number we plug into here is one from 0 to 8,760, which doesn't really help us very much, and you probably don't want to calculate that yourself. So they have given us think it's this one right here. Yeah, LB calculate. So we can calculate the hour of the year, the HOY, by plugging in various numbers to this this handy dandy guy right here. So if you hover over this, you can see this is month, so it needs to be from 1 to 12. This is integer from 1 to 31, hour from 0 to 23. And if you wanted to go as far as minutes, you could do that too. So I'm just going to create a number of sliders here. So I'm going to do a number slider to 12. So you know, make it, we'll do today. So we go 4, the 4th month, day from 0 to 31. Oops, that's not what I wanted. So today is the 15th, so let's go to the 15th. And then hour, we'll do right this second, which is 7/18, which is what, 1900 hours, 1918. So we'll do a number slider from 0 to 23, right? 7, 8, yeah, 1900. So I'll go to 19 right there. I won't go as far as minute right now. But if I put a panel here now with this all plugged in, you'll see that HOY is plugging out a number of 2,515. So that's the hour of the year that we're currently in right now, 2,515. So I can plug this directly into this HOY command up here, and now I should be getting the data that's coming out, the sky matrix that's coming out is for this specific hour. If you will go back and I'll show you, actually I'll do it right now. So this is showing me an hour of this specific hour, but you could also say, I want the hours for, I want the course of multiple days or multiple hours. So to do that, you would just need to create a series of numbers. So if I was to do, let me just copy this down here. I can create a series, which gives me, will give me a bunch of different numbers. So I can say, I want to say I wanted all the hours up till now. If I plug this into counts, let me undo. You'll see that I should now have all the months. So I have, January, February, March, April, 0 to 3, right? Actually should probably, yeah. So that will give me that full, all the months till now. And I can create other counts, plugging this count into here. This will give me all the days up till, basically from 0 to 15. So I guess it would give me the first 15 days of every month. So if I wanted it to be all of those months, I have to up this to 30. You have to watch out because if the months, if there's not 31 days in a month, it might bail out and it might error out like that. So I'm just going to keep it at 30. And so that gives me those days, and I can create another series here. I can grab all the hours of the day right there. Make this 24. Oh, that's because I have a 0 in there. So I won't make it 24. I'll keep it 23. Okay. So then I can plug these in. And then if I plug a panel into here, it should give me a series of numbers that are all the various hours, hours of the year that we could grab. So I could plug this into here. I could get all the days from then till now. So if you wanted to get a series, like a full month or something like that, this might be, this is the way you might want to start to do that. Because if I wanted all the days in March or in April, I could do that and I'll get all of the hours, HOY hour or whatever in April. So I'm not going to use that for now. I'm going to do kind of a specific day. I'll leave this down here just for funsies. But so now that we have our sky matrix, which is really the only thing we need out of this node, we need to get bare minimum. We need to do the geometry, create the grid size, and then set this to run, right? So the geometry, anybody have any idea what we want to plug into this geometry? So this is the geometry that it's going to get the radiation off of, like kind of, it's going to create our grid that it will read. So to make it simple, I am going to grab turn off all these. I am just going to read the radiation off of this surface, which is, pretty much what we're, I'm creating I'm using a plane that's similar to what my, my skin is, and that's where I'm going to read the radiation at. So if I plug this loft down here into the geometry, this will be where it starts to read that data from. So the other thing I definitely need to do is set the grid size. So the grid size is basically how minute of a square is it gonna kind of calculate on. So this just needs, if you hover over it, you'll see that the grid size just needs a float, which is kind of which is an integer number, right? So I'm just gonna create a slider to 10. Put it at 5 for now, and I can plug this into the grid size there. I can also do an offset distance that offsets the amount that the reading comes off, so it's a little more visible. So I can just do, I'll just set a, you don't have to set it, but I'll just set a small offset so it's a little easier to read when it pops out. So does anybody want to know? So the last thing it says is parameter run failed. And it says down here, if I go to the run parameter, it says hint Boolean. Does anybody know what that means? Or what a Boolean is?
You have to make the Boolean toggle and set it to true.
Love it. Boolean toggle, we got false. So before I do this, I'm just gonna save because it's gonna, after I hit true, it's going to, run, and I don't want it to crash and lose what we've done. So to set the Boolean toggle to true, I'm gonna double click on it, and then we got this. So it's not looking that crazy. So let me turn off my preview here. It's all blue, mostly because probably the sun's down at 7 o'clock on, I don't know what the sunset is. It's still light outside, but I'm guessing it's actually set. So I'm not actually getting any kilowatt hours of radiation on this surface. Well, and I guess in Pemba, I don't know actually. Well, Pemba is in, I don't know where it was. And Pemba is, okay, yeah, it's southern hemisphere. So it's actually winter going into fall, winter time. So yeah, it's definitely set in Pemba. So we need to change our time. Oh, I also put midnight. Oh no, I use this one. So it's 7 o'clock. So 7 o'clock in Pemba is not really giving us a good reading. So I will set my time back here a little, and you can see, so at 9 a.m., you can see that this side is, very, a high kilowatt hour, and I'm getting a lot of shade on this side. So, I'm sure if I push this forward a little, that's going to kind of start to float around. It's actually going more and more to the left there. So maybe if I bring it back, you can see that it kind of moves across the facade throughout the day, right? So that's our incidence radiation. Back to here, you can see that if I, change this to be higher, that it changes that grid size. If I make it lower, it makes it a little tighter and gives me, it's a lot more accurate, but it'll run a lot slower. So I'm actually going to keep it a little high for now because we don't need it to be that, 100% accurate there. So I'm going to use the 5. And so now, does anybody have any idea what we need to do now that we have this information? How we might leverage this to replace our opening and closing. So the idea would be that where it's most red, where it's the highest radiation, we probably want those panels to be closed so they're not, sun isn't blasting through into our, inner canopy or whatever you want to call this pavilion. And where it's, less radiation, it's more open, and they can open gradually across there. So anybody have any ideas what we might need to do to get that to happen? So I have a bunch of things coming out. So this is my radiation, right? I have a bunch of things that pop out on this side. So the two things I want to leverage most, well, the thing I want to leverage most is the results, right? The results, if I plug in here, is a series of numbers that relate to this scale. So this is the kilowatt hours per meter squared. This is the actual calculation, right? And like we talked before, they're just numbers. So the higher this number is, the more kilowatt hours, the smaller I want my opening to be. The lower this number is, the more open I want my panels to be. So the results are the number one thing to leverage. But does anybody want to know why can't, or do you think I can? I basically gave it away there. Why can't I just plug this here, plug these numbers into there? Does anybody know why? Or have an idea why that might not work the way we want it to? No idea?
Does it go too high?
Go too high. I don't want to plug it in because I'm afraid it might crash, but what do you mean by too high?
Like past 360, I guess.
Past 360? Oh, like 360 degrees, you mean?
Yeah.
It's actually too low. I mean, the numbers are 0.1. So if
Oh, yeah. I was looking at results. Never mind.
Yeah, so it would actually be.
I mean, yeah.
It would be too. It would be a little. It would rotate by 0.1 degrees. So you probably wouldn't even notice it. They all look like they were closed. So I mean, that we will actually have to deal with that as well. So that'll happen. That'll be another thing we have to deal with. But the main reason why I can't just plug this, I could just plug this in to this number or to this degrees. One, Earl, you're right. Instead of too high, it's going to be too low. We're not really going to notice anything. But the bigger problem is that these values are at specific places on this surface. And where 0 is, so you can see I have a points element coming out. So if I plug my points in here, maybe if I make it a point, these are all my points, right? So if I was to grab the first point, it'd be funny, it may actually get, if I was to grab point 1 here, that's probably a bad example because it actually is going to be close to our first triangle. But if I was to grab point 100, which is right there, so that's point 100. So that is the 100th point in this list. So if I was to scroll down, it'd actually be number 99. So it's this point right here. And if I scroll down over here, I could look and find number 99 in this list. And this is the corresponding, so 99 in this list is the corresponding value at that point. Interesting. But that doesn't, point 100. So if I was to plug this number into here, it would make, because it's a list of 100, it would make the 100th item in this list which would be the 99th item, the 99th list, this surface. So if I grab list item here, see if we can get this to look right. Let's flatten that. And I'm going to get 0. So if I grab the 100th item in there, where are you? Oh, there it is. So this is the the triangles. If I can plug all these in, I can get all the triangles at that spot. Hopefully. Hope that didn't work the way I wanted it to. Let me undo that. Disconnect. Plug this back in. So that triangle does not correspond to that point. So if I was to plug this list of 100 values into here, it would rotate this triangle by the value that's at that point, which would be the exact opposite of what we want, because we want this to be more open and this one we want to be more closed. Because this list is almost 1,000 items long, and this list is only 374 items long. So I can't just plug that in because it just doesn't, they don't relate to one another yet. There's no relation between where these triangles are and where these points are. And the way the Ladybug tool works is it creates a grid of points that are just across the surface based on this grid size that we popped in. And you can't really change where that, you can't say, oh, I want it at these specific points, at least in this node. So does anybody have an idea what we might want to do, or have a, maybe not how we do it, but what you might want to do to get that, to kind of correlate these two things together? And does that make sense? Is anybody confused by what I just explained? Because lists, as we've talked about before, are difficult.
Can you go over it one more time?
Sure. So I have, so let's imagine this. Let me pull these down. So this is kind of all my Ladybug stuff, right? This is how I'm generating this, the color map based on the radiation, all these nodes. The way it does that, the way Ladybug does that is it takes a ZPW file, which is weather data from a specific location on the planet that has, all kinds of stuff in it. It takes that location and it finds the radiation at that location. Basically, what's the diffuse direct radiation at that specific location on the planet at this specific time of year, right? So on April 15th at 6 a.m., this in Pemba, Mozambique, if you had north is probably up, we could change north too, but at that time, actually north is probably down because this is counterclockwise. So north, the difference between north and the y-axis. So yeah, the y-axis is north-south, so north is probably this direction. Anywho, so it takes the data from this place at this location and at this specific time of year. It brings it over here and it says, pick a geometry, right? So I need a geometry to map. So I picked a surface, the curved surface that we have, and it says, what's the grid size? So it makes a 5x5 grid, which you can kind of, imagine here, like a square, a 5x5 square grid looks something like this. And it says, what is the radiation, puts a point there and it says, what's the radiation at that point, facing the directions that it's facing, and it generates this color map, right? Does that all kind of make sense?
Yeah.
Okay. So it basically says this, at this point, the center of that grid, at that point, the radiation is whatever, is 0.12 meter or kilowatts per meter squared, kilowatt hours per meter squared. But it just generates a random grid, right? It's just generating a grid of 1,000 points. If I was to change this, make this a little higher, I made it 6. This list is now 674 points. If I, and the higher I go, the less accurate it gets, but and the less points it's generating from. So these points, there's just 1,000 points generated in a square grid, but we generated our triangles from a triangular grid, and there's only, if I come back over here, if I hover over that, you can see at the bottom there that there's 374 triangles. So we have 374 points. So if I turn preview this back on, so these are all my center points of my triangles. And, surprise, surprise, the center points kind of look like there's some sort of alignment at this bottom, but when you get up here and when you get over here, they're all over the map. They're not really close to, they don't align. So I have 374 points in this list, and I have 1,000 points in this list, and they don't align. So I can't take these points and find out what the radiation is at this specific point right here, because that's not how this node works. I can find out what the radiation is at this point though. So I need to relate my radiation data that I'm generating at all these other points to this point right here. So does that kind of make sense? And that's why this doesn't work. It's hard to explain.
Yeah, I think so.
So if you had the same amount of data points as you did triangles, would it work?
Probably not. So how many, let's see, I don't know if I can fake this. So I have 374 points, which isn't the number, isn't a round number. So if I turn this up, let's see how close we can get to 374, 674, 482, 359. So I have 359 points. It's kind of close, but it's not 100%. It would probably, I don't know why that's blue right there. It's interesting. I wonder why that's happening. So now the points kind of align. They're close. Not 100% correct, but let's say they're close enough. Like if you played with these numbers up here, maybe there's a world that you can get these to be exactly the same. But this is close enough for government work, so we can look at it at least like this. If I graph, so this node right here. So to check to see if it worked, I can grab the same number in a list in all of these lists and see if it aligns. So this node, I'm grabbing all the points out. So I can just plug this in here for clarity's sake. I'm taking all the points from this, I'm putting them into a point node, and I'm grabbing this grabs a specific item in that list. It's specifically grabbing the 100th item in this list. So you can see that point is right there. That's the 100th item in this list. And if I was to plug this in to here, it would just relate them one to one. So the number that's at the 0 spot would relate to this triangle that's at the 0 spot. The number that's at the 50th spot relates to the triangle that's at the 50th spot. So if I look at the same triangle, so you can see that's my 100th point, but this is still my 100th triangle. Nowhere close to each other. So, if I pulled this to 47, so there's my 47th point in my triangle, or in my, that's my 47th triangle is right there. And if I move this to my 47th point, right there. So you might not even notice it at this level of, you know, this isn't that fine-tuned in terms of the radiation, so that these two don't look that different. But if I was to fine-tune, if I was to turn this back up, you would start, you know, this really wouldn't generate that interesting of an opening. These would all basically be closed except for this line for some reason and a few at that spot. So I need to relate, these aren't relating to one another. So making the lists more closely related in terms of number still doesn't align the things together. Does that make sense? I don't know how to read your silence.
Does it make sense that they're not aligned?
Does it make sense that like we need to find a way to align them and understand why they're not aligned? Why I can't just grab this list and plug it in there?
It makes sense why it doesn't work, but I don't know what to do about it.
Okay.
Yeah, that's
Yeah.
what I feel.
Well, as long as we're on the same page as why it's not working, because you might run into these things, because you might look at a data set that has 1,000 points in it, 1,000 data points, or you know whatever, but you only have 50 panels. So it's like, how do you relate those two lists together? So you need to find a way to kind of mesh those lists together. So now that we're at least, I feel like we're on the same page as why it doesn't work. How we fix it is, I'm going to turn this back down a little bit to get some more clarity, some more fine-tuned details in here. So how I fix it is kind of simple. I need to find, so the points I care about, the points that I care that where the radiation is, or what the radiation reading is at this center point, because that is where the center of all my triangles are. You know, if I turn my triangles back on, you know, I care what's happening at this point in this triangle, because that is how it's gonna open and close my shading device. So I need to figure out, the thing I need to figure out is what point is closest to this one. So for here, it's pretty simple. For here, this point is pretty simple. I want to know what that point reading is. For this one, I want to know what that point reading is. This one's a little, you know, maybe it's that one, maybe it's that one, but I want to get close. I want to find the closest reading, you know. So the finer tuned I make this, you know, the smaller I make this grid, you know, the more fine tuned it can get. So what I need to do, I'm going to save this I'm going to save these nodes so that way we can see that it works later, is I need to find the closest point. So this node will basically take the points that are my like data points, and then a cloud of points, and then relate them together and say, from these points, this is the closest, you know, from the points coming in here, using these points coming into this part of the node, the points out of these are the points that are closest out of the cloud, right? So what I want to plug in is I want to take my center points, my centroid points, and plug them into there. And then I want to plug my cloud of points into here. And then what I should get is, so now if I plug in my closest point list here, circumvent that, I can get the 47th, let me flatten this for a second so I can get, hopefully flattening it won't hurt me here, but so here's my 47th point, and coincidentally, this is my 47th triangle. So you can see now they're a lot closer together than they were before. Maybe it's not 100% perfect. You know, could I get a little, you know, maybe that point would have been better. I don't know. I think that one's probably pretty good. But you can see that the 47th point in this list now aligns with the 47th triangle. And if I change this to, if I go back to, if I go to 77, and I make this 77, you can now see if I come over here, 77 is closely aligned to the 77th triangle. Like I said, is it 100% perfect? You know, maybe that one would have been, you know, this point's kind of in the middle here. So, you know, maybe that one would have been better, but it's not, you know, it's never going to be 100% perfect. I could, like I said, I could turn the grid down even more and maybe get a little closer. But you're just upping the calculations your computer has to do. So this is you know, probably the best, you know, for calculation purposes, this is the best way to get that. So now if I was to copy this out and I grab this, you'll see that I only have 374 points, which coincidentally is how many triangles I have, 374. Does that make sense?
Yes.
Okay. So now that I have that, I could just plug this in. Or I could plug the, oh, so I shouldn't just plug this in. And the reason I shouldn't plug this in is that these are points. I don't want points. I want the results, right? So anyway, I have an idea how I relate these two together. How do I get the results for these points? So this node offers a few outputs. So I can find out what the closest point is. I can find out what the distance is between the 2 points. And then I can also find out what is the CP index, which is the closest point index. This gives me the number, quote unquote, the index number. Does everybody remember what index number means? What this is telling me is that this, so if I'm at the top here, let me get 2 panels. Plug my points into here. So index is the number of an item in a list, right? So this is list 0. This is the zero item in that list. They're all 0. They're all lists in lists. But if I was to just for a second flatten this, I have a single list, and these are my index numbers. It's just where something is in a list. So this point 0. This point is at the 0 point at the 0 item in the list. But what this is telling me here is this point, even though it's in the 0 item of this list, this point index is saying it's in the 37th item of this big list. So if I was to go, paste this out, if I was to grab the original points here, like so, and I scroll down to item number 37. I get 37 at the top. I'll put it up here. So you can see that this point at 0, 6.127746, 6.127746 is it's 0 in this list, but it's the 37th item in the bigger list. And this is telling me that. It's telling me where it is. So I can use this, the item and index tool that we've been talking about and using occasionally to grab items. And I can say, let me unflatten these. and I can say that I want to grab. So the list I want to filter down is the results, the radians, right? I want to filter that list. So that's the list I want to filter, or I want to grab items from. And the index I want to grab them from is coming out of here. So these numbers. So I want to grab the 37th value from this list. I want to grab the first value, and I want them in this order because the order relates to how they relate to the triangles, because we use the closest point thing. So this list now is a list of all the values, the radiance values at the various points that we grabbed. So now this is the data that we want. Does that make any sense at all? Lists are incredibly difficult to understand, but is everybody struggling with that one? I can't see everybody, so.
Yeah.
Yes? Okay. Let me think of another way to explain it.
I get it. I just don't think I could do it.
You just don't think you could do it?
Like with a different set of data, maybe.
Mm-hmm. Well, this concept is the same for everything, right? So if you're using, the butterfly tools, or not butterfly, the butterfly tools, the ladybug tools, honeybee, or you're pulling in, you downloaded an Excel file that has 1,000 things in it. Well, that's a little less. That's probably a little. The Excel file, you don't need to worry about this as much. What you need to do in that regard is just you need to filter that list down. So you need to relate that list to the number of items you have. So find the averages. Like you have 50 panels and you have 100 data points. You need to kind of filter that list down to kind of match the size that you want, right? This is useful for when you're using the Ladybug tools or maybe other add-ins to get a bunch of data. So this would be particularly helpful for sun data, the wind stuff that people are trying to do. Some people are trying to do temperature or humidity or things like that. So this is how you might use that tool. Use these data points that are generated from these add-ons to do that. I mean, the process is essentially the same or similar. So how do I explain I think of it if there's an easier analogy to explain this. Lists are incredibly difficult. They seem simple because it's just data in a list, quote unquote, but how you manage them is difficult. But I feel like you all are running into, there's chats. Okay, you're talking to yourselves. All right. Let me see here. Maybe I can draw something. So let me go into a blank spot over here. Okay, so I'm going to draw off my mouse, so forgive me. I have, so the way Ladybug is working is it is taking a surface and it's splitting them into a series of points. And those points you know, it's creating a grid of points, similar to how we were doing a tractor point stuff. And each one of these points has an X, Y, and a Z location, you know. So it's taking those points, and then from those points, it's calculating the kilowatt hours. And the node that calculates that pumps it out in two lists. So it says, you know, this is kilowatt hours per meter squared. 1, 2, 3, 4. So list 1 is the point that it is creating, and then list 2 is the kilowatt hours per meter squared at that point. So item 0 in, so when I stop this for a second, let me go to, so list 1 is the points, and list 2 is the results. So these two lists relate to each other. So item 0, the point at item 0 coming out of here, and the point and the kilowatt hours at item 0 relate to each other, because this, at this point, it's this kilowatt hour. At this point, it's that kilowatt hour. So they 100% are a one-to-one relation. The problem we run into is that we have a separate list, you know, list 3 over here, which is the center point of all of our triangles. And this is an XYZ point. But this list, this XYZ and this XYZ are in two different locations because they're generated in two different, completely different ways. So they can't be, you can't just plug this, you can't plug this number into this list because like we saw, the location of that point is not in the right spot. So what we did was we created, we used a node to figure out, to go into this list and say, hey, which one of these points, 0, 1, 2, 3, and 4, are closest to these points? And we got this other list. So list 4. Oops. Undo. List 4. And list 4 says basically, well, this is at point 0, the point that is closest to this point is 0, and it's actually in this list, it's actually point number 3 is closest to point 0. So then it says, hey, the third item in that list over there is the one that's closest. And then point number 1, so that's this guy right here. And then point number 1, item in our list 1 that is closest to that is actually point number 2. And you can go on and on down this list, and you could say, oh, this is point 4, this is 0 point, whatever. So it's relating this list to this list, and it's saying these at these items, at item number 3, point number 3 is closest to point 0. And it just so happens that we know that these two lists are related to one another. We know that 0 and 0 are at the same spot, 1 and 1 are at the same spot, 2 and 2 are at the same spot. So I can use these numbers, these 3, 2, 4, 0, and I can say, hey, I want to pool the item. So I need to relate this list to this list. So I need, this diagram's getting crazy. So list. I can create a node that I plug this list into, and I plug these numbers into, and I say, put this list, grab the items that I'm saying. So take item number 3 in this list. Let's say this, you know, let's say item number 3 in this list was, you know, Dane was my name for some reason. It'll say, hey, in the zero spot of list 5, which is the last one, hopefully. I'm running out of colors. Let me erase some things here. Whoop. In list 5, we're going to create the final list, the list to end all lists. At the zero item, which, because we related these two together, so we know that at this point, which is 0, it's the closest point to it is 0.3. So we know that item 3 is the value that we want. So I'm saying, hey, at item 0, take the third item in this list and put that at 0. So we'll put Dane right here. It's just reorganizing this list in a way that makes most sense. So then let's say my wife is here. She's Diana. So she's at 0.2. And it would say at 0.1, or, so in the second item in my list, grab the second item, grab item number 2 out of list 2. So it would take Diana and it would put it here. And it's really just reorganized. So, and so on and so forth. It's just saying, taking this list and reorganizing it in a way that relates to this list. Does that make any sense? It's just a way to reorganize these things so that they relate to each other. Danny was about to write something or do something.
I clicked it by accident.
Oh, okay. Does it make sense to you, Danny?
Slightly lost, but at the same time, I get it. Just a lot to take in.
Yeah.
I think I got it until there were 5 lists.
It's definitely going to be something
It's okay.
to look back over.
So let me see if I can find some better things or some better like tutorials or something that explain this a little better. But basically, you think about Excel and you have the A's, the A and the A, B, C, D at the top and the 1, 2, 3, 4, 5 on the left. Those are just lists that you are saying in column A1, what's there. Lists are very similar. They just have two, they just have an A column and a B column, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down to infinity. So it's literally just trying to kind of organize it in the right way so all the data relates to one another. Can't explain it much better than that at this moment. I'll try to think of a better way. And if I can't, I'll definitely look up tutorials or something that explain it in a better way than I'm explaining. So know that you need the thing to take away from this right now is that when you're plugging data like this and relating it to one another, you need to make sure that the right data is aligned. So that's the takeaway. And hopefully over the desk grits, when you run into these problems, we can problem solve them together rather than you getting stuck. This will be on the final exam, yes. Lists are difficult. I'm not surprised that it takes, I still only probably understand them at a 30% level out of 100. Other people are much better at them than I. So I'll move on past here. And as we run into these problems in your scripts, I will do my best to help explain why these are problems and how we can fix them. Just know that with this node and this closest point and grabbing the right results, I now have related the result closest to the triangle. I've related the location of the triangle to the result that is closest to it. So moving on from there, now we just need to figure it. Now that we have all the right values and all the right numbers, we need to get this data in a format that makes sense to rotate our triangles. Because right now, if I rotate it by 0.07 degrees, it's not really going to do me much good. And this, I'll say to Laura, Beth, and Cole, if you're listening, this is what we were trying to do. What I'm about to do is what we were trying to do at like 9:15 last class. So if you haven't figured out how to remap your values, this is my tutorial on that. So if you didn't understand anything up till now, pay attention here. And a lot of you may need to do this with some of your data. So what we need to do with this data is make it into numbers that are more palatable for rotation of these panels. So I need to do what in Grasshopper is called remap the numbers. So I want to take all these numbers, I want to keep their relativeness the same. Like I want the panels, the highest number to still be the highest number in this list, the next list, and the lowest number to be the lowest number in this next list. So we're going to remap the values, remap numbers. So what this node does is it takes a set of numbers and it takes the highest and lowest point in that, and then you tell it what the new highest and lowest point should be. And then it makes the lowest number in this list, the lowest number that you tell it to be, the highest number you tell it to be, and then everything else is in between, spaced out relatively apart. So what we need to do is remap them. So in order to remap them, we need the original values, which these are our original values coming out of this node, our results. So I'm going to pull that into here. And then I need to tell it two different things. I need to tell it what the source domain is and the target domain is. And does anybody know what domains are? Some of you have had those nodes in your definitions. But so does anybody know what a domain actually is?
Is it like a set of data, or is it a formula?
It's kind of like a set. It's basically a low number and a high number, and it will say from 0 to 200, or from 1 to 2, and it encompasses that range of numbers. So it's kind of like a set, but it's not every single number. So if I said from 0 to 100, there isn't 100 items coming out of there. 0, 1, 2, 3, 4, 5, 6, and so on. It's just literally, it just says 0 to 100. So if I was to construct a domain, there's a node called construct domain. I'm going to use the typical one. I tell it where I want it to start and where I want it to end. So my target is where I want it to change all of my numbers to. So I want the target to relate to the degrees in which I am rotating. So I might say that my start point is 0 because I want at the smallest end, I want it to be closed. I don't want it to rotate 360 degrees. I only probably want it to rotate, let's say 50 degrees. So I'll put the number 50 in to this guy. And if I hover over here, you'll see it comes out one locally defined value, 0 to 50. So it's just saying from A to B and all the numbers in between A to B. So so this is my target. So I'm going to plug my target into here. And my source, so the source is, this might be also confusing, but these are all my values. This is the list of my values, but I need to find the domain of my values. So I need to find the lowest number and I need to find the highest number. So in order to do that, I can do, there is a command called bounds, which gives you your min and max value out of a list. So I can plug my numbers into here, but we're going to have a problem, and you'll see why in a second. It is because these numbers are in a list, they're all in individual lists. It's giving me the min and max value of all the individual lists. And there's only one number in all of the lists. So the min value is 72414 and the max value is 72414. So it's not really going to work for us because it's not the min, not the singular min and singular max value. Anybody know how we might get what we need to do to get, what is the lowest number in all of these numbers and what's the highest number in all of these numbers. Anybody know what we need to do to this node to change how this comes out? We need to do, oh, good.
Is it like the opposite of graph?
It's flatten, so it's just kind of the opposite of graph.
Okay.
So if I flatten it, so all I did was right click and click flatten. I just unclicked it. It takes all these numbers, combines them down into a single list, and I can now see that my lowest number is 72414, and my highest number is 0.12069. So now, if I plug that into my source, and I put a panel here, you'll see that my numbers have all changed. So coincidentally, the top number was the lowest number. So you can see the lowest number is 0 now. And if I scroll through, you can see I got 49, 40, 48, 10, I'm sure if I look through here, there's some other zeros. So there's a similar value. Oh, there's 50. So there's my highest number. That's the maximum amount of radiation on a given spot. So that has remapped all my numbers into more palatable numbers for my angles. So now, if I turn my stuff back on up here, preview, I'm going to I got my triangles back. Let me turn off and turn off all my stuff here so I don't see this. There we go. So got all my triangles back. So now if I were to plug these numbers, my mapped numbers, into this degrees, like so. Well, actually, let me save first. Anytime right before you're about to do like a big calculation, make sure you save. Okay. I mean, it does do a good job of saving things, but so if I plug that into there, you'll see, ta-da, now I have them all opening at different values. So you can see I have closed ones down here. I have a lot of big open ones up here. And they all they gradually change across. Does anybody know why we're still not there yet? Let me see if I can turn on so here's my radiation underneath. What is wrong about these openings and how they're opening and closing? So all my closed ones are down here, all my open ones are up here. And this is actually kind of what Laura Beth and Cole, the issue you were having when you were trying to get your heights of your wall to change in the right way.
You want it to be the other way around, right?
Yes, I want it to be the other way around. I currently have the widest open spot is where the darkest red is, which is where the most sun is. So unless I'm trying to, bake people in the sun underneath of this canopy, which might be what you want to do, I want to reverse what's happening. I want the panels to be the opposite. So the easiest way to do that, anybody have an idea how I might reverse it?
Don't you have to do like the inverse?
So I was actually wrong. There's an easier way to do it. I thought that. That's what I thought Tuesday when I told you and Cole.
You faked
what's that?
You faked us out.
I did. Well, I mean, you can do it that way, but there was an easier way to do it, and I'm not as math savvy as I thought I was. So what I told Laura Beth and Cole on Tuesday was they were having a similar issue. I was like, oh, well, just take the inverse. So take the numbers and take, 1 divided by all the numbers, and then they'll all flip, because then it would be the highest number, let's say, is 100. 1 divided by 100 is smaller than 1 divided by 2. But then you need, which you can do it that way, but then you need to like now we're back in a world where the numbers need to be remapped again. It's probably not the way to do it. So the easiest way to do it, and I can't believe, I don't know why I didn't think of this until later, was in order to get the highest number to 0 and the zeroest number, the 0 number to the maximum number, is I can do a math equation, a subtraction, and I can say, make a number slider, and I can say, make the number slider 50, and say that 50 minus these numbers gives me a new list where my 0 item is now 50, because 50 minus 0 is 50, and my 50 value, 47, 50 minus 47 is 2. So it's flipped all my numbers around. So wherever 50 is in this list, or in this list here, should be a 0 in that spot. Oh, there it was. Saw for a second, but either way, yeah, it's a 0 item there. 217. If I scroll down here, 217, I have 50, right? So it's basically flipped all those numbers by taking whatever your max value is here. If I really wanted to, I could plug this directly in. So if I changed it, this changes and the relationship stays the same. Now I can plug this number, this value, into here. And now it's flipped. So all of my blue spaces that are more, have less direct sun are more open, and all my red spaces that have the most direct sun are closed. And of course, if you wanted them all to be open a little bit, or something, you wanted to, I don't want it to ever be perfectly closed. Maybe I always want it to be a little more open. You could add a number back in, say, oh, the minimum value is going to be 2 degrees. You could just after you add or subtract here, you can just add in, whatever that minimum is to up that 0 value to a lower number, or a number that's not 0. So that is, and then if I wanted to just see what that looked like, come over here, I can bake this onto, let's put it on layer 2, and go like that. I'm just gonna lock my curves so I don't grab them. They're on layer 0, go like so, move that over, and turn this to Arctic for now. You can see that I have more open panels here, and they transition to closed panels here. And if I went back to the beginning here, I'm going to hide turn off that preview for a second. And I changed my time of day. So let me change this up, move this up. I can start to see there's a lot of sun. Let me move this to 4. Let me put this towards the end of the year. So they're changing. There's a lot of sun in Pemba. So I'm assuming this top is always going to be closed most of the time. And if I go to all the way to the end, they'll start to open up, and they open up at nighttime because there's no sun or less. If I go in them, so they react to the sun at different times of day as I change all of these items. And I could do it for the whole year. I could do multiple renderings and see all the different possibilities that come out of this. And obviously you can do, it doesn't have to be triangles. It could be louvers. It could be something else. You just have to, relating that information is the hardest part. And if you really wanted to get crazy, I won't go into this, but, you could, now that I have all these surfaces, I could, make them thicker. So I could extrude them so that I had a panel, actually had a panel size. I could use, so that it looked like a thickness. I could go back to my curves here, and I can grab certain versions of these curves and create some structure out of it. Even if I wanted to do it quickly, I could create a pipe, curve, and I can get some create a structural, some sort of structural grid off of that, and start to make it look more and more realistic. Like it's actually a piece of architecture. That was a tough one, guys. I don't know if, I hope you learned something out of that. I know that's a little more complex of a script, and I'm sure you may have seen these online looking at these. But these are the kind of things that you may get into. Maybe you don't get into that level, but you'll find these are like the ideas or things that you may need to kind of start to grapple with when you are putting all of your inputs together. Because this is all of this down here, basically everything that's in this list. I may as well call this, this is my input. This is my output. And then all of this here, and some of that down there. Is my process. So that's my IPO. I'm getting all my inputs, which is my sun. I'm processing all of that input into in this, with creating my shape, and then I have my output, which is my final form. And who's to say, some of you have different things, like, you're trying to do multiple inputs. All these sliders could just be different inputs. So my, maybe not my radius, but like my depth of my triangles, where is that? Oh, right there. So, is that the depth? No. Oh, it's right here. This is my depth. So this could be, the depths of the triangles could change for some reason or another. That, for some other input that you're calculating, the number of triangles could change. This might crash, but we'll see what happens. Based on something, so all of these can just be different kinds of, values that you're pulling in. Cool. So let me just save this. I'm going to, does anybody have any questions about the script before I stop recording? Or about this in general? I'm going to stop recording.